Hello, my name is Allan Hipolito, and now I will resolve a task scheduler problem in LeetCode 621. The difficulty is a medium problem. In my opinion, it is more harder than medium. So this is a problem. You're already given an array of CPU tasks, each labeled with a letter from A to Z, and the number n. Each CPU interval can be idle or allo. So tasks can be completed in any order. We have a constraint here. There has to be a gap of at least n intervals between two tasks with the same label. I will explain more than this uh, after. Alright, so you need to return the minimum number of CPU intervals, the minimum of the time required to complete all tasks. So let's go to the whiteboard. So in this example here, I have tasks with 3A, 3B, here with n equals 2. So in the order of execution, we execute firstly the letter A has in time 0, alright? So in the next, we execute the letter B with the time is 1. And after we go to idle. Why we go to idle here? Because the number n equal 2, meaning that we have at least 2 times to allow the execution of A again, alright? So only in the time 3 the A is allowed. So something to the letter B. So because of this, we have a idle here. So after this, we have a and letter B again, idle again, A, B, and idle. So the total time is H. All right. Let's go to another example here. I will copy that and put here again. So enter example here. I have A, C, A, B, D, B. All right. It's a mixed values. It's have a lot of different values here. So I will execute later A. After doesn't matter the order, I'll execute later C. Right. So I can execute a little A again. So I can execute a little B, D, and B again. So have a 1, 2, 3, 4, 5, 6. All right, the output here is 6. Is the possible sequence is this sequence that I take a note here. So explain it. Let's go to the code. Before we go to the code, I will explain how the Max-Heap will work together with a queue. All right. So in this example, have a slight difference. I remove a B here to explain better. So in the Max-Heap, we'll have most frequency values. So we have a -3 first, and after we have a -2. So basically, we use a negative values because the Python don't have a fit, don't have it's harder to work with a main heap because the Max-Heap instead is the better solution of this. So but in another language like Java, I think is have another ways to deal with it. All right. So we have a -3 and -2, and the logic here always that you put this guy in the queue. We will put basically the number of this increased by 1. Increase it will decrease it because -3 go to -2, alright. In positive values, alright, you use a -1 instead the positive ones, alright. So in this queue we have the main is2 value and the value that he will enable the period. So we stay in the period 0. So the formula is the period increased by n. So you have a 2 here, alright? So I will line up this one, and after we go to the number 1, alright? So basically let me copy that, and I will line up this one, and we'll have a -1, alright? And number 3, that is 2 more 1, alright? 2 increased by 1. So basically we have real 2 value. So this guy is enabled here, alright? So I remove this one and put this one here, alright? So we have in the 2. I will line up this one. We'll go to the -2. You will go to -1, and we'll go to the 4, alright? And we have a 3 value here, alright? So alright, this guy is the 3. So I will delete this one, and this guy will be -1, alright? And here we have a 4, so I will line up this one and increase it, this guy at 0, and 3 more 2 is 5, right? So this guy will be 0, and when we have a 4, I will put a -1 here also. So I delete this one. I think you got the idea. Alright, so have a 4 here, -1. So I will go to actually line up this one. So I will have 0 here, 0, 0. Alright, and at this period is 6, 5. Alright, so I have 5 here, 0. So I delete this one. I go to the 6. That's it, the 6. I will line up this one, I forgot. And then we have 0 at here. I'll delete this one, and this is the end. Alright, we have the 6 that we return in the code, alright, into the example here. Alright, so let's go to the code right now. So in the code here, the first thing that I need to do is define the count has a counter of tasks. This is a function counter, make easier the thing to count everything in the array. Alright, so we define the Max-Heap equal to minus count for count in counts dot values. So we call the heap key dot heapify, that is we put the max heap. So here we return the values ordered in decrement. So I will print this one here, and now have a -3 and -3, alright. So the next we define the time has 0 and the key has a DQ. So while Max-Heap or key is true, the time will increase yourself by 1. If have a Max-Heap, the count will be defined a heap key dot heap pop calling the Max-Heap, alright. And if we have a count key dot append, so we'll use a DQ. We'll append the count and the time increase it by n, alright, as we'll call it before. And here in the final of this, if we have another if with a key is true and key in position 0 and 1, that is, we'll getting to the value of the queue. We have the queue, and we have alright, don't have nothing here, but we have to get the first position element in position of the queue and get the time, alright. And if a key in position 0 is equal to time, what you're gonna do, heap key dot heap push that you see before, calling Max-Heap, putting key dot path left at 0, alright. So here we putting again in the heap the value of key in position 0, alright. So this value here is important, will be increasing or decreasing. How you works with negative values will be increased, and these values you go to the heap, and here we putting this code in the heap. This part of the code is responsible for do this, alright. And in the final we will return the time. So we run this code, alright. Let me fix the indentation. So alright, accepted. Alright, I will speak about the time complexity and space complexity. Alright, so but before to go to this one, I will speak that the values here is real value is 7, that's 6. Alright, that speak before. Sorry, this is a mistake. Sorry. And 7 is the final number of the real count of this array that you have. Alright, so basically speaking about time complexity of this algorithm here, we have a counters, heap phi, DQ, alright. So the time complexity will be a n times log k, alright. Log k represents actually k represents a distinct values, alright, and log k is these steps to resolve this one. And n is the number of values, alright. So basically it's the time complexity. It's not the time complexity could be speaking about all n, but it's a mistake because here we have a 6, but the real value at step h is h, right? It's not 6 because we have idle values here. There is the CPU down able to process this one because the A and B is not able. So we have this idle times here and they're increased to 8 instead of 6. All right, so here we don't have idle. All right, so here actually is all and. So you could do, have in mind that if you don't have idle times, the time complexity is all n, right? So, but in your worst case, that it can be idle, it's all n times log k, right? And space complexity is all k being different values, right? So the space complexity don't will increase more than key distinctive values of k. So basically that is it, and that's it. This is a stack shadow problem 621 LeetCode, and thanks for watching me. Bye bye.